Welcome back, guys. So in our previous videos we had talked about all the questions from 6.1 up to 6.17, and in all of those questions, whether these are some specific real world problems or not, what we also had some mean value, we had some standard deviation, and in our real world values, what we have done, first of all, we have converted all of these values into the z domain. And what was that? If we had some value that was x minus mu divided by sigma, so equivalent of it was z, and then we had found out all the probabilities by using the z distribution table. Okay, so this was basically the theme in all of our previous questions. Similarly, in question 6.18, what is the statement? The heights of 1000 students are normally distributed with the mean of this and a standard deviation of this. Okay, we are given this mean, standard deviation. Assuming that the heights are recorded to the nearest half centimeter, how many of these students would you expect to have heights less than 160? Means the probability that x is less than 160 centimeters, okay, between this value and this, okay, and equal to 175 centimeters, greater than or equal to 188.0 centimeters. Okay, so this is the first part of this question. What do we have to do? This is the small x, and similarly here, what we will do first, we will convert it into the z, and then after it we will use the z distribution table. It would be very easy because it is already in the formulation, that probability that x is less than 160, and then it would be probability that x is less than z. Similarly, in b, between 171.5 and 182.0 centimeters, so what do we have to do here? It will be the probability that x is less than z2 minus the probability that x is less than z1. Okay, what is z1 and z2? This is, let me call it x1 and let me call it x2, and for each of them, for z1 it will be x1 minus mu divided by sigma, and for z2 it will be z2 x2 minus mu divided by sigma. Okay, similarly here you have to convert it into z greater than or equal to 188.0 centimeters. It is the probability that x is greater or equal to 188.0 centimeters. We cannot find it directly because the z distribution is in the form that x should be less than the value of x. So it would be what? It would be 1 minus the probability that x is less than 188. Okay, so this is what we have to find out. This 188 will be converted to the z, and then by employing the z distribution table we will find out the solution. So this is all about question 6.18. In question 6.19, what is the statement? The statement is, a company pays its employees an average wage of this with the standard deviation of this. Again, we have the mean, standard deviation. If the paid wages are approximately normally distributed and paid to the nearest cent, okay, what are the options here? Part A of this is, what percentage of the worker receive wages between this value and this value, which is just like part B of our question 6.18. The highest 5% of the employees hourly wages is greater than what amount? Okay, so here the probability is given here. What is given? That probability that x is less than or equal to z, and this is also given 0.05, which is 5%. First we have to find out the value of inverse of this 0.05. from it we will get the value of z, and from that value we have to find out the value of x, which is x equal to mu plus sigma into z, which is from the same formula which we had previously discussed. Okay, so this is for part B. In question 6.20, the statement of the question is the weights of a large number of miniature poodles are approximately normally distributed with the mean of 8 kgs and a standard deviation of 0.9 kgs. If measurements are recorded to the nearest tenth of the kilogram, find the fraction of these poodles with weights this over 9.5 kgs means probability that x is greater than 9.5 means this is the 1 minus probability that x is less than 9.5. Why less than? Because we had to convert this one and this one to the z, and in z distribution table we cannot imply it for the values where the value is greater than some specific value. B is of at most 8.6 kilograms. Again we had to convert it to the z and then find it out, and between this and this, again the same question as we had here in part A and we had in question 6.18 part B. Okay, in question 6.21, again the tensile strength of a certain metal component is normally distributed with the mean this per square centimeter and the standard deviation of 100 kilograms per square centimeter. Measurements are recorded to the nearest 50 kilograms per square centimeter. So part A is what proportion of these component exceeds this value per square centimeter in tensile. Means this is x is greater than 10,150. So it is what we have to convert it into the z value, and to convert it into z, this is the formula, and after converting it we have to use the z distribution table, which is not applicable over this formula because this here x is greater than this. So therefore what we have to do, we have to find the value which is less than 10,150 and subtract it from 1. Here we will get it. In part B, if specifications require that all components have tensile strength between this and this, again the similar one as of this part C, per square centimeter inclusive, what proportion of pieces would we expect to scrape? Okay, so similar one we have to find them out and then we will find the answer of it by employing the z distribution table. Okay, so now question 6.22, which is somehow different than the above questions, and we will try to solve this question in our upcoming video. In these questions, try to solve all the questions, but this part B is for you. You have to practice it out and we will also discuss it if you have any question. So that's it for today, in which I have discussed all the questions which were relevant with our previous videos. If you have any question, you can ask me in the comment box. See you soon. Welcome back guys. This is the exercise problem 6.22, and the statement of this question is if a set of observations is normally distributed, what percent of these differ from the mean by part A of it is more than 1.3 times sigma or 1.3 times the standard deviation, B less than 0.52 times sigma or 0.52 times the standard deviation. Okay, so let us first solve part A of my question. So the solution, okay, and in solving part A of my question, the information is at the 1.3 times sigma from the mean. So if this is the normal distribution, and we can see here that this is mean, and let's say this is what, this is 1.3 times sigma and this is minus 1.3 times sigma as well. Okay, you can see that both of them are 1.3 sigma away from the mean. Okay, this is 1.3 sigma times away from it, and this is also 1.3 times sigma away from it. So therefore we have to consider both of them here. Okay, both of these sides will be included because in finding out the distance both of them are included. Okay, so what is this distance equal to? If this is mean, so this point will be at mu plus 1.3 sigma. Okay, and this point will be at mu minus 1.3 sigma. away from it. Okay, so you know that these are the 2 points. Now in order to find the probabilities of them, it can either be this one or this one, or countering both of them, because the information or the percentage we want to find out here is this one and this one. These are the areas or the percentage areas we want to find the percentages of which. Okay, so in order to calculate it here, it would be the probability that x is greater than mu plus 1.3 times sigma, plus the probability that x is, this is the less than mu minus 1.3 times sigma. Okay, so these are the equations. Now in order to proceed further here, we remember that exactly previously x was equal to what? When we wanted to convert any information from z to x, what we used to do, it was basically mu plus z into sigma, and this was basically from what? This was from z equal to x minus mu divided by sigma. Okay, from it we got this one. Now here you can see that these are the similar formulations. You can also see here that this is the similar formulation, and here we can see that the value of this z is here and the value of another z is here. So let me call it z1 and let me call it z2. So therefore it would be the probability that x is greater than 1.3 or z1 plus the probability that x is less than minus 1.3. Okay, these are basically the probabilities. Now similarly here you can see that this information is similar as this information is, because this normal distribution is symmetrical with respect to this mean. So therefore both of these percentages are the similar. So therefore now only considering this one, because this basically corresponds with the less than sign, so adding both of them, it will become what? Let me call this one and these, as these two are equivalent, so therefore this is equivalent to minus 1.3 as well, and this is the original x is less than minus 1.3. so therefore it would be the 2 multiplied by the probability that x is less than minus 1.3. okay, now this is what? This is in z distribution, and in order to find out this probability, what we can do, this is the similar formulation, and in order to find it out, we can move to the z distribution table where we had to find out the probability that x is less than minus 1.3. so let us move there. So x less than minus 1.3, here it is. Okay, so this is the value, this is here minus 1.3, so it is 0 0.0968, 0.0968. okay, and multiplying it with 2, 0.0968 multiplied by 2, it would be what? It would be 0.1936, 0.1936, or it is what? Let me solve it here. It is 19.36%. okay, so the area which is more than this value is 19.36% of the overall normal distribution. Okay, so that is what? That is basically the solution of part A of my question. Now let us move to part B, and here that value is less than 0.52 sigma. okay, so let me solve it, and here this is the normal distribution. okay, so 0.52, let me have here 0.52, and this is minus 0.52 because of the similar reason which I explained here, and these are the two values, and in finding it out, this is basically the area, because now here the probability that x is less than 0.52 sigma Okay, this is the area, and after solving it like this one, we will get that this would be the value of z1. So here it will be the z1, and also here the probability that x is greater than minus 5 2. Okay, combining them both, we can also write it like probability that x is greater than minus 0.52 and less than 0.52. Okay, so in order to find out this probability, so it would be the probability that x is less than 0.52 minus the probability that x is less than minus 0.52. Okay, so let me find them out by the z distribution table, and this would be, let me write it here as well, that is 0.52 minus the probability that x is less than minus 0.52. Okay, so first let me find it out. So x is less than 0.52, so this is 0.5. okay, this is 0.5 and this is 0.52, so 0.6984, 0.6984. okay, and minus x is less than minus 0.52, so minus 0.52 is minus 0.5 is here, and this is minus 0.52. let me see. No, this is incorrect because this one is the 0.5. okay, this is incorrect. 0.30153, 0.30153. okay, so let me solve it here. So it would be 0.6984 minus 0.30153. so this is 0.39687, 0.39687, which is equivalent to 39.7%. okay, and this is the solution of part B of my question. okay, so you have seen that how we have solved it and what are the intentions behind these type of questions. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.23 of chapter 6, and the statement of this question is the IQs of 600 applicants to a certain college are approximately normally distributed with the mean of 115 and a standard deviation of 12. okay, so mean is given here. Let me write the given data here as well. The number of students, let me write it as n equal to 600, and mean, let me write it as mu is 115, and standard deviation, which is sigma, that is 12. If the college requires an IQ of at least 95, how many of these students will be rejected on this basis of IQ regardless of their other qualifications? Note that IQs are recorded to the nearest integers. okay, so here the value of x, which is the threshold, that is 95. so we want to find out that how many students will be rejected on basis of this criteria. okay, so first of all, what do we have to do? We have to find out the value of z so that we can use the z distribution table. So here z is x minus mu divided by sigma. Let me write the value of x, that is 95, minus mu, which is 115, divided by sigma, which is 12. so this is minus 20 divided by 12. so let me write it. So 20 divided by 12, how much is this? This is 1.67. okay, so this is minus 1.67 because of this sign here. So now this is what we have. Now we want to find out what? We want to find out the probability that x is less than or equal to minus 1.67, and to find it out we have to use what? This is the z value, so therefore I have to use the z distribution table. So this is the z distribution table, and we have to find the value of minus 1.67. so minus 1.6 is here. Okay, this is the row of minus 1.6, and the column of it is this is 67. So this is the value for this one. So minus 1.666 this, and minus 1.67 is here, 0.0474. 0.0474, and that is what? That is the probability that x is less than or equal to minus 1.67. So this is the probability that the lower IQ than 95 will be this one. But we want to find out the number of applicants out of these 600. So now in order to find the number of applicants out of the 600 which fulfills this criteria would be the number of applicants multiplied by the probability 0.0474. okay, so let me multiply it. So 600 multiplied by 0.0474, so this is how much? This is 28.44. okay, 28.44 or around 29 students. okay, so the answer of it is around 29 students or 29 applicants will be here, that who has the IQ of at least 95. okay, so that is what? That is the solution of question 6.23. if you have any question you can ask me in the comment box. See you soon.